1.3 is solving quadratic equations. Okay? And today you're going to solve quadratic equations using graphing and using square roots. Okay? A quadratic equation is an equation that can be written in the form ax squared plus bx plus c equals 0, where a is not equal to 0. Now this is called the standard form of the quadratic equation. Okay? Now if I look at the picture here, okay, you can see that, let's see, the quadratic equation can be solved by a variety of methods. We already talked about that. One way to solve a quadratic equation is to graph the related quadratic function, and the solutions of the equation are the x-intercepts of the related function. So, x-intercept, where the graph crosses the x-axis. So, in this graph, those are my solutions. Okay, those are the solutions of the graph, of the function. So here, -2 and positive 2 are the two numbers, that when you put it into the equation, it gives you a true statement. Is everybody clear? All right. So a quadratic equation can have 1, 2, or no real number solutions. Okay, and we'll talk about that a little bit more in a bit. Okay, the solutions of a quadratic equation and the x-intercepts of the graph related of the related function are often called the roots of the equation or the zeros of the function. So problem 1 is solving by graphing. We want to know what are the solutions of each equation, and these are the 3 equations. Maybe we'll just do 2 of them today since we're short on time. These are the equations that we're going to be graphing. Okay? Now, when we graph, we want to, for A, we have x squared minus 16 equals 0. All right. So the first graph that I want to put on this coordinate equation is the parent function. You guys remember the parent function is just y is equal to x squared, right? Okay. So when we graph the parent function, we're just graphing y is equal to x squared. Okay? So we've got 0 squared is 0. We have 1 squared is 2. Oh, 1. 1 squared is 1. 2 squared is 4. Okay, 3 squared is 9. And so forth. Is everybody clear? So because there is a line of symmetry right down the middle at the on the y-axis, we can put the other side of the parabola, and this is what your graph looks like for the parent function. Okay, so that is what the graph looks like for the parent function. If you look at this equation, x squared minus 16 is equal to 0. What does this tell you is going to happen to that parent function? It's going to move down 16 units. All right. So this negative 16 tells us that we're going to transfer down 16 units. So that means that each one of these points that we have on the parent function is going to go down 16 points, right? So here, this is 0, 0. We're going to be down here at 0, 16. You got that? Over here, this 1 is going to be down 16 units right here, and so forth. So all of the points in the parent function have moved down 16 units, so that is what your graph looks like. Is everybody clear? Now, we want to know what are the solutions. Where do they cross the x-axis? Where do they cross the x-axis? At -4 and +4. Very good. So the solutions of this of the first equation is -4 and +4. There's my graphing using the parent function. Okay, we can also graph by finding the axis of symmetry and the vertex. Okay, so let's do the next one, the 3x squared plus 6 equals 0. Let's do that one with that method. Okay, so 3x squared plus 6 equals 0. Is that standard form? No, what are we missing? We're missing the middle term, which is the bx, right? So what we need to keep in mind is that this will be written as 3x squared plus 0x, right? That would be a 0x, that just is nothing, plus 6 equals 0. So that is our new equation, and that's what we're going to use to find our axis of symmetry. So the first step is to find the axis of symmetry. So finding the axis of symmetry, we're going to use our formula, -b over 2a, right? Well, our b is 0, right? And our a is 3. So when we put that into our equation, we're going to have a -0, which is just 0, right? Over 2 times 3, which gives us 0 over 6, which is just 0. That is our x coordinate for the vertex. Remember we talked about that yesterday? So now to get the y, we're going to take that 0 and substitute it back into the equation. Okay? So, to find the y, we have 3 times 0 squared plus 0 times 0 plus 6. Well, that's 0 plus 0 plus 6, which is just 6, right? So our vertex is at 0, 6. So now we need to find two other points to put on our graph. So we've got our x, and we've got, we can go ahead and leave the 0x out now, just because we're just going to substitute in. So we're going to have 3x squared plus 6, and that's going to give us our y. So let's just do 0 and 1. Okay? So we have 3 times 0 squared plus 6. That's going to be 6. Huh? What's that? Isn't that our vertex? Yeah, that's our vertex, right? So let's add another one in here, and let's do 2. Okay? All right. So we've got 3 times 1 squared plus 6. So that's going to be 1 squared is 1 times 3 is 3. So 3 plus 6 is 9. Right? Then we have 3 times 2 squared plus 6. So that's 2 squared is 4 times 3 is 12 plus 6 is 18. Okay, so now we have two other points. Is everybody clear? So now we can go ahead and put our points onto our coordinate grid, okay? So let's start with our vertex. Our vertex is 0, 6. So that's 0, 1, 2, 3, 4, 5, 6. Our axis of symmetry is right on that vertex. Okay, that's our axis of symmetry. All right? All right. And now we can put the other two. So we've got 0, 9. I'm sorry, 1, 9. So this is 1, that's 6, 7, 8, 9. And then we've got 2, 18. So this is 2, that's 9, 10, 11, 12, 13, 14, 15, 16, 17, 18 is up here somewhere. Right? And now, because we have our axis of symmetry, we can put it on the other side. So we've got, let's see, 1 unit away over here, and 2 units away up here. So our graph looks like that. You got that? But I thought our solution is where it crosses the x-axis. Am I crossing the x-axis at all here? No. Because we are not crossing the x-axis at all, there is no real number solution. So let's just write no solution. Is everybody clear? All right. So no real number solutions because the graph does not cross the x-axis at all, right? Now going back up to the other one, somebody asked, where is it crossing the x-axis? It crosses the x-axis right here at -4 and 4. So yes, that means that this has 2 solutions. You got that? So moving to problem 2, we are solving using square roots. Okay? We can solve equations in the form x squared equals k by finding the square roots of each side. You're going to say, that is so easy. So, here, all we need to do is solve for our variable. So in order to do that, we're going to add 36 on both sides, showing our work. We get m squared is equal to 36. And how do I get m by itself? Take the square root, because the square root is the inverse of the square. So, we get m is equal to, now when you take the square root of a number, okay, you get 2 numbers, 2 answers. You get the positive 6, and you have the negative 6. Because 6 times 6 is 36, and negative 6 times negative 6 is also 36. Very good. So this has what? 2 solutions. Everybody. So here we're going to do the same thing, solving for x. Okay? So we're going to subtract 15 on both sides. We end up with 3x squared is equal to negative 15. Then we're going to divide by 3. And then x squared is equal to negative 5. Right? And then to get the x by itself, we will take the square root. So now let me ask you this. Can I find the square root of a negative number? No. Is there a number that you can multiply times itself to get negative 5? No. No, there is not. So, when you have the square root of a negative number, what do you think your answer is? No real number solutions. Got it? Okay. Let's just do the last one. So here, again, solving for d, we're going to subtract 16 on both sides. This gives us 4d squared is equal to 0. we'll divide by 4. So d squared is equal to 0. How do I get to d by itself? Square root. So d is equal to what? 0. Positive and negative? No, because there's no such thing as a negative 0, right? It's just 0. So, how many solutions? One solution. All right, problem 3 is choosing a reasonable solution. You can solve some quadratic equations that model real-world problems by finding the square roots. In many cases, the negative square root may not be the reasonable solution. So here, an aquarium is designing a new exhibit to showcase tropical fish. The exhibit will include a tank that is a rectangular prism with a length L that is twice the width. The volume of the tank is 500 feet cubed. What is the width of the tank to the nearest tenth of a foot? All right, so volume is length times width times height, okay? It says here that the volume of the tank is 500 feet, so that goes here. It also says that the length is twice the width. So L is going to be 2W. The width is just going to be the W. And from the picture you can see here that the height of the tank is 4 feet. So now we can simplify. So we've got 500 is equal to 2W times W. That's going to be 2W squared times 4. Okay? Simplifying some more, of course, 2 times 4 is 8. So this is going to be 500 is equal to 8W squared. And now we're just going to use the square roots. So we're going to solve for the width. So we're going to divide by 8 on both sides. So W squared is going to be equal to 62.5. And now we can take the square root of the the square root on both sides, and we end up with W is equal to 7.9056 something, something, something. Now it says here, let's see, we don't want to have, doesn't tell, oh yes, here it is. It says to round to the nearest tenth of a foot. So the 9 is in the tenths place. The 0 tells us what to do. So the width of the tank is going to be approximately equal to 7.9